Anybody remember the command from 347? It's similar if you had a static IP.
IP DHCP client.
No. IP, address, DHCP. Just like that, guys. That's it. Now, same thing, gotta no shut it. Hey, looky there, came up. Now, what's going to be really interesting is if it actually gives me a DHCP address. That's kind of cool. I don't think it will though, over wireless. Show int f. Yeah, it won't do it. Wireless. Kind of cool if it did, but don't worry about it. Let's just say, for posterity's sake, that we got an IP address.
Can you raise your command line a little bit?
Sorry.
Thanks.
No problem. All right, so next on R1. So looking at this, I'm just going to lower this so you can see the topology. Let's not talk about security stuff yet. Let's just talk about basics. We've brought up the interfaces. What's the next thing we have to do? No, that's security. Think about this just from a networking perspective. What does the router have to do? Route. Exactly. So, I have no routing set up on this sucker whatsoever. It's not going to do a doggone thing. Okay? So, let's just say, for example, right now, I have a packet that comes in to my fast Ethernet 01 with a destination of 12.42.86.25 in the IP header. What's that router going to do with that packet? It's going to drop it. Why is it going to drop it? Because there's nothing in the routing table. There's nothing in the routing table to process it. If I look at the routing table, anybody remember how to look at the routing table? What's the command? Show IP route. There's nothing there. Period. Bupkis. Right? So, first thing I have to do is I need to set what type of a route? A default route. Very good. What is the command that I use to set to do a default route, or any static route for that matter? IP route, good.
0.0.0.0.
Yeah, that is your catch-all. Now, since I'm using DHCP, this is one of those little caveat things. If this was a static address here, and I knew what the other side was, I would put that IP address here. Okay? That makes it unicast. Okay? Unicast, much more efficient. Easy to route. Less chance of drops, less chance of problems, less chance of broadcast, etc. But since I'm using a DHCP, and what's one of the fundamental things that a DHCP address will do from time to time? It'll change. It'll change. Now I could easily, if I'd gotten an IP address on that interface, I could have figured out what my gateway was. And I could put the gateway here. Right? But what happens if that gateway changes? problem of DHCP. Right? So what is better to do is just put the exit interface in this situation, since I'm using DHCP. So in that case, it would be IP route 00000000, fast Ethernet 00, or F0/0 for short. Okay. Now if I do a show IP route, that interface is down, that's why it's not going to hit it. It's not going to hit the routing cable. There. You see it. Okay. Yeah, it's still not going to be there because it doesn't have an IP address on that interface. All right, no problem. Let's move on. Let's just assume real quick that that did take shape. Now, let's work this in reverse. Let's say that I have a packet that comes in fast Ethernet 00, destined for 204.186.21.25. What's going to happen to that packet on R1? What's going to happen to that packet on R1? It's going to get dropped. Why is it going to get dropped? Because it will not exit out the same interface it's received on. Rule number one. Rule number two, just like before, there's nothing in the routing table. If there's no entry in the routing table, it gets dropped by default. Okay? So, now let's make a static route in R1 that points to the ASA, this IP address here, for this network. Sir?
Question. Then what was the route 0000?
That was a default route. So what a default route does is it will, if there's nothing else in the routing table, it will send it to that in that direction. But since it is coming in the direction that it goes anyway, it can't route back out the same direction.
Oh,
Okay.
so that packet that was sent from the...
That packet that was coming in on this interface, all right, since it was coming in on this interface, it will get dropped because it cannot exit. That's something called split horizon. Split horizon, all right, cannot work that way. That's to prevent routing loops.
Okay. Thank you.
All right, so IP route 204.186.21.0, 24-bit subnet mask. Where do I send it? But what do I have instead of F01? That worked for DHCP, but what do I have that's different?
Oh, yeah, the static.
I have an IP I can send it to. What IP do I send it to? It's on the board. You just gotta look for it. 204.186.201.18. Now that one will show up in the, oh look, hey. So it did show up finally. Did I get an IP on that? Did I get an IP address on there? Oh, I did. Oh, that's kind of freaky. Alright, show IP route. So now, I did show up in my routing table. Okay? Now I can do all the same stuff there for R2. Let's do a couple of, now that we've addressed those interfaces and we've set the routing up, all right, I want to take you through just some of the fundamental steps of setting up a firewall. And it's very similar to setting up a router. All right? Now, if you guys remember from lecture last week, what are the 3 things that that a firewall must do? Any firewall. What's one of them?
Inspect traffic.
Inspect traffic or filter traffic. What's the second one? Don't answer it. Can you? Translate. NatPat. And what's the third one? What does a firewall also act as? A router, so it has to route. Very good, ISIS. All right, so those are the 3 things it has to do. I'm just going to take you through the third one tonight, how it routes. So you've seen how routing is done in the router. I'm just going to show you how it's done in the ASA. I'm also going to show you how the addressing works for an interface. You have to do a couple things, all right? You have to not only give it an IP address, you also have to name the interface and set a security level, okay? The security level and the naming of the interface are twofold. One, the name of the interface is going to be used in all kinds of stuff. Routing, NATing, access lists. You don't refer to an access group via the Ethernet interface, you refer to it as the Ethernet interface's name. The second thing it's going to do is it's going to, with the security level, you basically set up a zone-based firewall. Okay, a simple zone-based firewall by implementing a security policy for the via the security level. So the simple rule is the higher the security level, the more secure the interface, or the more secure the zone. The lower the security level, the less secure it is. Traffic can pass from a higher number security interface to a lower security interface without having to be inspected. Traffic cannot pass from a lower number security interface to a higher number security interface without inspection. It automatically is dropped. Okay? Everybody clear on that? We covered that in zone-based firewalling. Same holds true in an ASA firewall, or any firewall for that matter. All right. So let's go ahead and go back to the console as ASA. So to get into global configuration mode, guess what the command is? Config T. Uh-oh. When you get this message, hit no. I don't want to get calls from Cisco system as to why I'm pirating their software. Work the wise. Hit no.
How'd you get into the console on that? Mine says network error.
Really? I just hit right click to hit console.
Okay, that's it.
Really?
It says network error, connection refused. Restart in 2 or 5 seconds. And then it loops and it does the same thing. But I was trying to open it. Oh,
I don't suppose we can get a copy of that,
Copy of what?
of what you're doing, of this project here.
We'll see. Actually, I'm more concerned right now because you can't get to the ASA.
Can get anywhere.
Do you get the Quemu page?
that comes up.
You
Closed out of it.
don't close out of it.
That's probably why.
Don't close out of it.
So I
You need it.